Hello there, this is Miss Nakayama, and today's lesson is 2.8 Quadratic Inequalities. So you've done everything in this lesson. We're just kind of pulling topics from previous lessons and putting them into a new type of problem. So we've got quadratic inequalities. All right, that means that we don't have equals in each of our statements. They're quadratic because we're going to have an exponent of 2 on each of them. You can use algebraic or graphing. And doing quadratics, I decided to make this the easiest for you by choosing the graphing method. So honestly, it will only work for quadratic inequalities. You'll have to change things up unless you know the graph when you get anything higher than a quadratic. But let's start off. Solve x squared minus 3x minus 4 less than 0 algebraically. So when we're doing that algebraically, we are going to have to solve that quadratic. And that means find the critical values. So we're solving it, and this one you should easily know that it factors. So that's going to be x minus 4, x plus 1. And that is less than 0. Now, the critical values are what makes it equal to 0. So x is equal to 4 or x is equal to negative 1. Those are my critical values. The second thing I'm going to do is to make a number line using those points of 4 and negative 1. So on my number line, negative 1 is to the left, and then we have 4. And then we're going to sketch a graph on that number line. So when you go back to this problem, okay, a is positive, so this parabola goes up. So it's doing something like this. Let's hope I can, okay. These points of x negative 1 and 4, because it doesn't say equal to, are not included in that. But this is the sketch of my parabola, and the point of this is to keep in mind that this right here, if you think of this line, the number line, as your x-axis, the graph is positive here, and negative here. Now, another way you can think about it is you could think about replacing y here, and this says y is greater than, and if y is greater than, then I'm shading inside my parabola. I would, if I were shading it on a graph, and you'll have some of these in your homework so you can look at it, okay? So that's how it would be shading. And so look at my number line at what part is actually shaded. What part is shaded is the points between negative 1 and 4. But the other thing I want to point out to you is that this quadratic is less than 0. And which one of these is less than 0? The negative numbers are less than 0, so I'm going to write my solution, write my inequality in interval notation, and it is between negative 1 and 4, so that's my answer. So I've done it from a graph. You can also plug numbers in, and if that's how you want to do that. Okay, I'm going to keep going. All right, so the next one, 4x squared plus 8x minus 21 is greater than or equal to 0. Again, solve it algebraically. I'm expecting to see you solve this quadratic. It does not factor, but, and when I get rid of the a, so if it doesn't factor, I'm going to use completing the square because 4 goes into 8. So that first step of solving, to divide everything by 4, I'm going to get x squared plus 2x plus blank. I'm going to take that 21 to the other side, and that's going to give me 21 over 4 plus blank, because I had to add, divide by 4 in that first step. So then, what do I add? I add 1 to both sides, 1 squared or 1. And my left side is going to factor 2, x plus 1 squared. 21 over 4 plus 4 over 4 is 25 over 4. Then I'm going to take the square root of both sides. And remember, on the left, I'm going to get x plus 1. On the right, I'm going to get plus or minus 5 over 2. Then I'm going to subtract my 1. And then I'm going to combine. Negative 1 plus 5 halves is 3 halves. And negative 1 minus 5 halves is negative 7 halves. So it's a little more involved to solve that algebraically. All right, step 2, put that on a number line. Okay, negative 7 is to the left of 3 negative 7 halves is to the left of 3 halves. Okay, and then the next thing I'm going to do is graph it. So looking back at my original one, it's A is positive. So again, it's going to go up. I'm going to go ahead. Oh, all right, this time my points are included. Okay, which means we'll have brackets in our answers. But this is my graph going up. Okay, and again, as I mentioned, if I think about shading, okay, that's a Y. That says Y is less than the graph. So I would shade outside of the graph. And I can go ahead and do that. So, wait, that's not what I wanted. I wanted this one. Okay, so I could shade outside. So think about what part of my number line, what part of the orange is in the shaded area. The other thing, another way to think about it, and whichever one clicks for you, y'all, is that the graph is positive here because it's above the line. This is above the line. This part is below the line. Now, this says I want my expression that is greater than or equal to 0. So this time I want the positive regions. So again, it correlates with this orange piece of the graph. So what's my inequality? It's going to be 2 pieces. Okay, and I'm going to have negative infinity to negative 7 halves, and then union 3 halves to infinity. And that's what our answer looks like. Okay. Last example here, solve 3x squared minus x minus 5. Okay, I would not consider completing the square here, y'all. It doesn't factor because there's no factors of 15 that subtract to give me 1. If I were to divide by 3, that would still be an odd number. So in this case, I'm actually going to use the quadratic formula to find my critical values. So a is equal to 3, b is equal to negative 1, and c is equal to negative 5. When we plug it in, we've got negative b, negative 1 is positive 1. B squared is 1 minus 4 times a, which is 3. C is negative 5 all over 2a, which is 3. And I've told you, you always want to get that discriminant. So I'm going to say that's 1 plus or minus. And what you get underneath should be 61 and all over 6. So you'll need the decimals because the next thing we're supposed to be doing is putting it on a graph. So you need to plug those in and get those decimals. Make sure you can do that. X equals negative 1.14 and 1.47. So these are the corresponding spots on my number line. It is equal to, so it will include these points and be a bracket. Okay, again, this one is going up because A is positive. Oh, I forgot to say to graph it. That's the next point, graph it. That's what I'm doing. Okay, so I'm going to sketch my graph. And this, remember we talked about this being your y, and this says y is less than. And so y is less than means I'm shading below my graph, however it is. So what part of my orange number line is shaded? That's going to be my answer. But again, I want to let you know that this part of the graph is above the x-axis, so it's positive, and that's negative. So what regions do I want? I want the part that is positive. That's this part and this part. So last but not least, we're going to give our answer negative infinity to negative 1.14 bracket union bracket 1.47 to infinity. Okay, that's all. If you want to continue watching, I'm going to talk about the warm-up. I think it might have been a little bit challenging, but I want to go through it with you so to help you understand it and be ready for your quiz. So here it is. I gave you a little hint. You were supposed to match each inequality with the graph of its related quadratic function, then use the graph to solve the inequality. So, and I gave you a hint to look at the y-intercept to find the graph. So this y-intercept is 2. And which of these graphs, well, that one has a y-intercept of 2, and no other one has a y-intercept of 2. So that means that this has to go with graph A. Okay? What's the y-intercept here? It's positive 3. So I'm looking for positive 3. That one's positive 3, and that's the only one. So that means this answer is C. Okay? I'm going to go to C, and its y-intercept is negative. I didn't mean to do that. Its y-intercept is -3. So which one of these has a y? That's -2. This is -3 right here. So that means that C goes with graph E. I'm looking at D. These both have a -2. And so I'm going to go and do this one, which is -4. And which one has a y-intercept of -4 is D. So I'm going to go ahead and put that one down as D. And I'm going to go highlight the rest of mine. So these both have a -2. So what was left, what do we have left at -2? We have, that's not negative, we have this one and we have this one. So I don't know if you can tell, they look very close, similar, but this one has the vertex on the left, which means the graph was shifted to the left. This graph was shifted to the right. And if you look at this term right here, y'all, that if you were to complete the square would be x plus some number, which means I would shift to the left, which means that this graph has been shifted to the left, so it's going to go with B. So this one is B, and leaving me the last one with D. So now we have all the graphs, and go back and look. Okay, actually I'm going to change colors here, okay, to help you see. So this one, I want, however you wish to think about it. If you put a Y here, y'all, if you put a Y, I want to know the graph is less, Y is less than. So I'm shading out here. This is where I'm shading. If I were shading, if there were a Y in the graph, which you do have some of those. So that means my answer goes from that Y-intercept, or excuse me, X-intercept, and then this X-intercept that way. That's the answer on the graph. So if you were to write it, it would be -infinity to +1 union 2 to infinity. Look at C. B goes with graph C. So this one is graph C. So again, think about this being a Y. This says Y is greater than. Well, that means I'm shading inside here. And if I'm shading inside here, what part of the number line has been shaded? That's my answer. That means my answer goes, and it's equal to, so I have a bracket. My answer goes from 1 to 3. Look at C. C goes with graph E. Okay. Again, Y is greater than. If Y is greater than the parabola, that means I'm shading inside the parabola. Okay. So I'm shading inside. This is my number line. So that means that my answer is going to go between -1 and 3. And it's not equal to, so I don't have brackets. All right. B, no. Oh, well, D goes with graph B. Okay, here's my Y again. Y is less than, so I'm shading below. So I'm outside. That's below the graph, outside of the graph. And this part right here is what's been shaded. So that's my answer. -infinity all the way to -2. And it's a bracket. Union 1 to infinity. Okay? E goes with graph E. Again, here's my Y. Y is greater than. Y is greater than is inside because it's greater than that Y-intercept. So my answer is the number line between there and there. And that goes between negative, is that the right? Oh, poo. I wrote the wrong thing, y'all. That was supposed to be graph F. So that's why that's not matching. But pause for 1 second. Okay, I got it. We're going to come back to that graph. So this one goes with graph E. Y is greater than, so I shade inside. Inside between here and here. What part of that number line has been shaded is between -1 and 2. And again, it's not equal to, so it's not a bracket. Okay, this one goes with this graph. My Y is less than, so less than is shading outside, out here. and look at the number line. What part did I shade? I shaded this part. Negative infinity to negative 2, not equal to, union 2 to infinity. So, I hope that makes sense and helps make some sense out of the warm-up for you, makes it easier for you to understand. If you have any questions, y'all, please don't hesitate to email me or come see me. Thank you so much for watching, and y'all have a great day.